All right, good evening, everybody. I haven't done any astrophotography in about 2 months, and it's because the computer in my beloved Celestron CGE burnt up. Now, I think it was the power supply board. I don't know, a diode or a capacitor went bad or something, but it was broken. And rather than fixing that, only to have some other ancient component burn out a month later, I decided to build an entirely new control system based on the work of Howard Dutton and Khalid Bedalin. I don't know how to pronounce his last name. I'm sure I'm butchering it. And Dave Schwartz and a bunch of people. It was Howard Dutton's baby. But a lot of people have put a lot of work on an incredible open source project called Onstep. And it's a completely customizable telescope control system made of inexpensive, easy to obtain components, and you don't need to be a genius to build it. Some basic maker skills, basic electronics, soldering, basic computer programming, and you can build this thing. And I've got it installed in my CGE, and I just wanted to go over what I did. It seems to be working great. So let's change camera here. Oh, it doesn't look like you can do that on the fly. Okay, so that, if you know anything about a CGE, you know that is not what they're supposed to look like. That is a NEMA 17 400 step 2 amp motor. This is a 45 tooth pulley and a 15 tooth pulley to get a 3-to-1 initial reduction. I had to mill out the motor housing. You can see down there where it's chewed up. I had to mill out the motor housing to make room for that 45 tooth pulley. And I probably could have gone with a 50 and got an even better reduction, but I figured that was enough. I didn't want to push it. Modified the L bracket, the worm gear bracket to mount a NEMA motor to it, mount the stepper motor. Alternately, if you're going to do this, I thought another idea would have been to bolt it to the side going in like this, have the motor coming out here with the sprocket inside. That might have been easier. Maybe I should have done that, but I kind of wanted to maintain the original form factor. The original plate will still fit on here, the dust cover, so that's nice. It'll look nice. I built the STM32 Blue Pill version, mainly because of space, cost, and power. I wanted to fit it inside the original pier. You can see I've got it in there. I'm using the S109 stepper drivers. I made sure that USB port was available on the board. The kit that I got from Dave Schwartz. Great kit, by the way. Yeah, same modifications to the declination axis. So we've got a 180 tooth main gear here, and a 3-to-1 reduction here. And I am using 32 microsteps, and 16 microsteps for slewing. The max rate is set at 16. Or you know what? Maybe yeah, 8 microsteps for slewing. So 32 for tracking, 8 for slewing, and it's a pretty respectable slewing rate. Let me get I got Stellarium opened up here. Oh shoot, that was close. But you can see I just hit the right ascension controls here in Stellarium, and she's cooking. I had it out the other night. Tracking was incredibly accurate, very accurate. The guiding was really good. It was about 0.6 seconds of error, both axes. But yeah, it was pretty straightforward. I just followed the documentation that Khalid put together about the STM32, and just went from there. And there's a lot of helpful information in the Onstep group. A ton of information. You got to read all that stuff if you're going to build one of these. I also completely tore down the mount, cleaned and re-lubricated everything. There was a ton of old, gunked up grease in there that had gathered dust and metal over the years, and it was just like glue in there, and it was sticky, but it's smooth as silk. Now, I also replaced the worm bearings with ceramic bearings from Deep Space Products. They're like butter now. They're really nice and smooth. But yeah, other than that, the only main physical, I had to cut out a bunch of material under here for the motors to fit. Why is that not focusing? Come on. Okay. I had to cut down a bunch of material out of the motor housing here for the motor to fit, and modify this block and mill out some material here. Like that's where the switch used to be, but the limit switch used to be, but I cut that all out to make room for the pulley. But other than that, there wasn't a lot of physical modification involved. I'm running the S109s. They get a little warm, so I drilled some holes in there. I've got a fan in there for cooling, and the air comes out here, goes in here, comes out here, and keeps those drivers cool. I'm only running it at 1.4 amps. I ran it at 2, and the motors heated up. You could fry an egg on them. They got really hot. But I'm only running them. Then I ran them at 1, and they stayed so cool you couldn't even tell they were on. So I turned them up to 1.3 amps. Now we got a ton of torque. After about 2 or 3 hours, they feel slightly warm to the touch. Nothing that isn't normally dissipated. So yeah, I'm running them at about 1.3 amps. They seem to be working great like that. But yeah, there wasn't a whole lot of physical modification involved in getting this system into the mount. Just this L bracket. But if you wanted to, I think it would have been a lot easier to just cut that piece right off and just mount the motor going inward from the side of the box. It would have been a lot easier. Just would have required a drill. But yeah, we've got a clear night tonight. I'm going to try some astrophotography, and I'll get back with you on the results. And thanks a lot to Howard and Khalid and Dave and everyone else that put in the yeoman's work on an incredible project. And look forward to sharing my astrophotography with you guys.